So I decided to make a part 2 calculations video. I ended the last one on that table. I'll get to there. I just figured I'd split the calculations into 2 videos to make them a little shorter. Just to refresh your memory though, we've got pH equals negative log of the H3O plus concentration, or the H plus, same thing. pOH is the negative log of the OH concentration. Now, something that you'll have a little bit better grasp on, I'll actually full screen this here and get a pen. Let's get all of those. One thing you'll have a better grasp of is that if pH goes up, the pOH goes down. So as the H plus or H3O goes up, the OH minus goes down. So they go opposite of each other. That's why the scale for the pOH is flip-flopped. Bases are this way, acids are this way. This is obviously the pH scale. So just know that if the pH is 3, the pOH is 14 minus 3, it's 11, right? So it would look like this, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So the pOH scale is just the inverse or a flip-flop of the pH scale. So just keep that in mind. So let's quick head back to our table. There we are. So let's finish this table. I did the top row in the last video. I think I did part of this at the end of the video. So remember, the pOH times the pH equals 10 to the minus 14. So if I want to solve for this one, I just go 10 to the minus 14 divided by 0.01. Just a tad bit of algebra there. I divide it out on both sides. So 10 to the minus 14, let's quick type that in. 10 to the minus 14 divided by 0.01 equals 1 times 10 to the minus 12 molarity. Now it's pretty straightforward for this. If I want to find the pH, I just take the negative log of this. So negative log, just to make sure I don't mess things up here. 0.01 should be 2. Yep. There we go. So you got a pH of 2. Now you could take the negative log of this to get the pOH, but it's probably easier to say this plus 2 plus what equals 14, and 2 plus 12 equals 14. So yeah, that's probably the quicker way to do that one. Same thing here. 2.5 plus what equals 14, and that is 11.50. Now to go backwards here, to go this way, I need to take 10 to the negative 2.5. That's how you go backwards. So I go 10 to the negative 2.5, and you get 0.00, we'll just go 316 on that molarity. Now you can either do the times equals 10 to the minus 14. I find it easier just go 10 to the negative 11.5. I find that's easier to type into my calculator. And you get 3.16 times 10 to the minus 12. Now let's double check this just to make sure we did our math right. Let's go this times this, and it should equal 10 to the minus 14. So I'm going to go times 0.00316, and I get 9.99 times 10 to the minus 15. If I round that up, that is 1 times 10 to the minus 14. So these are your answers for the table. Let's go ahead and solve some of these. What is the pH and pOH of an HCl solution with a concentration of 0.025 molar? So again, this is an acid, so I'm going to write out the dissociation reaction. All that means is that I take the H and the Cl and I split it up. So I know that this is a strong acid, so that means that 100% of it breaks up. So I'm left with 0 molar of this. There's none of it left over. That means all of it turns into this. So the concentration of H plus is 0.025 molar. Concentration of this is also 0.025 molar. But that really is irrelevant because all I care about is the H plus. So to find the pH, I just take the negative log of the H plus concentration. So I take negative log of 0.025 molar, and that is equal to my pH, which is equal to, hold on a second, negative log of 0.025. I get a nice 1.6 for my pH. Now to find the pOH, I just go 14 minus 1.6, and that equals my pOH, which is equal to 1312.4, seems right. Did that one in my head, so if I screwed it up, you can correct me in class. I think that's good. So all it asked for was the pH and the pOH, so I got both those. I'm good to go on this problem. Now this one's asking a little bit more. What's the H3O plus, the OH minus concentration, and the pOH of a solution with a pH of 6.23? So this is pretty much identical to the table we did at the beginning of the video, or just like a minute ago. So if I know my pH is 6.23, to get my pOH, I'm just going to go 14 minus 6.23, just to make sure I don't make a silly mistake here. You should get 7.77 for your pOH. Let's just circle that, make sure we got that labeled. So notice I showed my work, and I labeled it as the pOH, and then I circled it, so make sure you're taking the time to do that on your worksheet. Then the next thing, now that I know my pH and pOH, the easiest way to find the H plus concentration, in my opinion, is to just go 10 to the minus pH, which is this, and that equals, let's see here, 10 to the minus 6.23, 5.89 times 10 to the minus 7. Your units are molarity, and that is equal to my H plus or H3O plus concentration. So then I circle it. Now I could either take 10 to the minus 14 divided by this number, and that'll get me my pOH. But if you don't type this in right, the order of operations can come out wrong because it'll divide by this, but then multiply by that. So I just think the safer way is to go 10 to the minus 7.77. That is equal to my OH minus concentration, which is equal to 10 to the minus 7.77. That is 1.70 times 10 to the minus 8 molarity. Don't forget to put molarity for your concentration. And that's an 8, by the way. And that it's asked for the H3O plus. I got that. OH minus. Asked for the pOH. Just double check. Make sure you got everything. Very similar. Try this on your own. And then pause the video and come back in a second. Okay, I'll assume that you did it on your own now. What is the H3O plus, OH minus, and pH? So we've got this. Easiest way to go from here to get the pH, go 14 minus 3.86. And just to make sure I don't make a mistake here, 14 minus 3.86, 10.14. That is equal to my pH, because this was my pOH. There we go. So I got one answer. 10.14 is my pH. Now I'm going to take 10 to the minus 10.14. That is going to get me my H3O plus concentration. And you got to keep track. This is your pH, so when you take 10 to the minus pH, that gives you your H3O plus. So 10 to the negative 10.14, and that gives me 7.24 times 10 to the minus 11 molarity. So I've got my H3O plus, my pH, Just for the heck of it, I'm going to go 10 to the minus 14 divided by this concentration, 7.24 times 10 to the minus 11 molarity, and that is going to be equal to, so I'm going to use the E button here. Well, actually, I'm not for that one. Divided by 7.24 and then E minus 11. And then I end up with 1.38 times 10 to the minus 4 as my OH minus concentration. And double check, I'm even going to do this a second way here, just to make sure. 10 to the minus 3.86, does it get me this answer? 10 to the minus 3.86, and I get the exact same answer, so that's awesome. So there's more than one way to do this. You can always do it 2 ways on a test just to double check. That is an option. The next video is going to be on indicators. So that's all of the calculation examples, and we'll have more practice in class. So I will end it there.